Today we're going to do some image processing. Specifically, we're going to edit images in C. Welcome back, folks. I hope you're all doing well. In my last video, I talked about PPM images, which is a particular format that I highly recommend for new programmers who want to get into image processing or working with images in their programs, want to fully understand the format, but don't want to deal with external libraries or complicated math. So check that one out if you missed it. Today, we're going to take what we learned in the last video and we're going to apply it to do some editing of some images in C. So of course, this video is going to have source code. All source code, as usual, is available through Patreon. Thank you so much for all of you who support this channel. If you've been watching the channel for a while and you're really enjoying the content, please do consider subscribing, liking, and helping us out on Patreon. However you choose to do it, I really appreciate it. Thank you. But now, let's jump into the code. Okay, so today I want to do two things. First, we're going to create a module that's going to allow us to read and write PPM images, and then we're going to make a tool that's going to take one image and modify it somehow. So first of all, let's start with the module. I'm going to call this PPM. So modules, you've seen these probably in other examples that I have done. Usually I have a .c file and a matching .h file. The .h file is the interface that we're dealing with. And so you can see I've got not much here, just some if-def guards and some includes. And let's come in here. There's a few things. So this is going to allow us to easily read in PPM images from files. And so let's start out by just making a struct, type def a struct here, and I'm going to call it PPM image. And let's basically say we've got some unsigned int, a number of rows. It's just information about the file. Let's do rows, columns, and so max value. Remember that in the PPM format video from before, this is what was stored in the header, right? You had the number of rows, the number of columns. This tells us how big the image is. And then the maximum value is like the biggest numerical value that a pixel can have. So like if this max value is 255, then if you have an RGB value of 255, 255, 255, then you're going to have pure white. Okay, so this is just basically tells us the size of the image. And then we also need to store the actual image data. So let's make a two-dimensional array of pixels. Let's just call, so we'll do pixel double pointer. So a pointer to a pointer of pixel type. And we'll call this pixels. Okay, now of course you notice this isn't defined yet. So let's come up here and let's just say that we want to make another struct and we'll call it pixel. And let's make this a uint 16 underscore t RGB. Okay, so each pixel is basically going to have 3 different 2-byte ints. I'm using 2-byte ints because based on the PPM format, that's as big as the values can ever be. So that should work. You could just make them ints if you want, doesn't really matter, but these are a little smaller, so it'll take up a little less memory, so that's nice. And then let's plan out some functions that we want to have. So one of these, let's say we want one that's like PPM read image. Okay, so I want to pass in a character pointer called file name. So this is going to take a file name that's presumably that file is storing a PPM image, and then we're going to have it return a PPM image pointer. Okay, so we'll allocate that on the heap and then just return that. So this will read in the image content from the file and it will malloc space for it and it'll return us a pointer. Okay, because we are allocating on the heap, we should probably also make a PPM destroy function that's going to take this PPM image pointer, that image, and it's going to deallocate it, make sure it cleans everything up. And then let's also make one that allows us to write. So we'll call this PPM write image. And this will also provide a file name. And then let's pass in a PPM image pointer, and that's the actual image we're going to write to the file. So this basically takes a file name and an image and it writes the image content to the file in PPM format. And this should probably return something. So let's maybe return bool. That way we can say true or false if it's successful or fails. Okay, so this is what our header file, this is what our module is going to provide. This is what it looks like. So let's jump over into our module and actually build this out. Again, just some header files in here that I'm pretty sure I'm going to need. But let's basically just grab these functions and implement them. So we'll come in here, give each of these some curly braces. Okay, so let's start with reading things in. You'll recall from the last time I talked about two different varieties of PPM image, the P3 ones, which are pure text, and the P6 ones, which are binary. Now today, just for simplicity today, I am going to only support the P6 images. Feel free to add that. You can add your own functionality to make it support P3s if you want. It should be pretty straightforward, but we're just gonna focus on P6s today. That's the binary format. Okay, so let's start with a couple things. First of all, let's just make sure we can open the file. So we'll just make a file pointer and call fopen, pass in the file name and read it. Binary format in case you're on Windows. If you're on a Unix-based system, that probably doesn't change anything, but Windows it might. And then let's check to make sure this succeeded. So if it did not, if we have an error, so if for some reason we couldn't open the file, then let's just print out an error. And we'll say something like, error could not open file. And we will return null. Okay, so if we get to this point, we know we actually have a file open, we could find it, that's great. Now there's a few things I'm gonna need. I'm gonna use mmap to read in the file. I think it'll be a little bit simpler. I guess we'll find out as we go through, but so what I wanna do here is get the file size. So let's just, for this, do fseek. There are a couple ways to do this. I'm just gonna fseek the file 0 to seek end. So what this is doing is basically just seeking to the end, and then I can, let's make a size t variable, call it file size, and then call ftell on the file. So that's going to get us the file offset. That'll tell us how many bytes were in the entire file. Okay, so that's gonna give us the size of the file. That's great. Also, when I call mmap, I'm gonna need a file descriptor. So let's grab a file descriptor from here. So we'll call that just file desc and set that equal to file no file. Okay, so all this is, I've talked about file descriptors versus a pointer to this file struct, fopen versus open in previous videos. Check out a link down in the description if you're unfamiliar with what I'm doing here. But mmap, which I'm gonna use later on, requires a file descriptor, and so I wanna make sure I have it. I can't just pass this file variable right here into it straight up. So instead I have to request the actual file descriptor that is stored in that struct. So now we've got the file size, we have a file descriptor. Now let's come back and just go back to the beginning of the file, and we will rewind the file. Okay, so this basically, because fseek here basically moved the current read position of the file all the way to the end, I'm just moving it right back. Okay, so now let's come down here and let's allocate space for our ppm image object. I'm gonna call this result, and we will malloc size of. Okay, so good. So we're basically getting the size of a ppm image, that's great. And now we can start reading stuff in. Okay, so the first thing you remember, if we look at our, so if we look at our ppm image, you remember that the first two things are this P6, and then we've got the width, the number of columns, and the number of rows, and then we have this max val. So that's kind of what we need to grab next. Basically, we need to grab this header information. So let's start off by grabbing the magic number, the P6 at the beginning, just so we can verify that it is actually what we want. So let's say it's like the file type. We'll make it a character array of length 3. Okay, and then I'm just gonna use fscanf to read in, and let's say it is a 2-character string. Okay, this is going to limit how many it will read to only 2 characters, and we'll put it into this type variable, great. And then let's just make sure that it actually matches. So we know that it can only be 2 characters because we specified it right here. So I'm just gonna use string compare, and we'll get type and make sure that it is P6. Okay, so calling string compare is basically gonna say, if this is not equal to 0, meaning this is anything other than a P6 right here, then we're going to assume that you got the wrong file, right? You tried this on something that's not a P6 ppm file. So here, let's just print out an error and say, this is not a P6 ppm file. Something like that. And then let's clean up. We know there's something wrong, so we'll just close file and return null. Okay, but otherwise then we're still going. So we found P6, that looks good. So let's read in the rest of it. So let's do another fscanf call file. We're reading from the file, and then the next line in the file is going to look like, basically we're gonna have 2 unsigned ints. And those are going to be the result calls. Let's store that. Okay, so we need a pointer. So this number of columns, we're gonna get the address of that. And then let's also get the number of rows. Okay, so that should get our columns and our rows. And then let's do basically the same thing, only there's only 1 on the next line of the header. And that is going to get our max val. Okay, so now at this point we should, if everything was successful, we should have our header information. Okay, now it is time to read in the actual pixel information, the actual, what the colors of all the dots in this whole image are. So what I want to do, first of all, basically the way this is set up is we've got the header information, right? So we've got sort of the header stuff here, and then we have the pixels, which are going to come right after it. So that's basically what this is going to look like. So what I need to do is figure out how far have I read into the file so far. So let's just make another variable here that's going to be our offset, and let's set it equal to, we'll use ftell again to get our current position after we've read all the header information. We're gonna get that offset. So that tells us how far we are, basically how many bytes are in this header. And then once we have this, then we can go ahead and read in the rest of the data. So let's just make this a uint t pointer. You could use a character as well, that could work, or an unsigned character. But this is gonna be my raw data. And I am just gonna use mmap to read it in. Also, if you have never seen mmap before, I do have videos on mmap. I'll link down in the description. You check those out if this is brand new as well. And this is not the only way to read in files. There, you could just use fread, or you could use fread here in this case, because it's binary data. You would not want fscanf for the pixel information, because it may produce it's not text. But anyway, mmap is gonna work fine for us today. So we'll pass in null, that's our hint. I don't care where this actually goes. I want the size of the file. We're gonna map that whole file size. And then I want it to be readable, not writable. And I want the map to be private just to this process. We're not gonna share it. And we're gonna need that file descriptor that we came up with. And we're going to map it starting at byte 0. Okay, so this is gonna map the contents of our file into memory. And then let's just go ahead and grab what we want to grab from it, which is our pixel information. But first let's check for errors. Okay, so if I say if raw data is equal to map failed, then we are going to, again, let's print out an error message, mmap error, and we will close our file and return null. That's also free result. Okay, so now we're actually ready to read the pixel information. Now what I want to do here is we need to first figure out how many bytes per color value, right? Because if you remember from the last video, these values, so you're gonna have red, green, blue, right? You're gonna have 3 values for each pixel, and depending on what max val was, these can either be 1 byte or 2 bytes. Okay, so what we're gonna do here is let's just do a quick check here. And I'm gonna say uint 8t, because it's gonna be 1 or 2. So bytes per value. And then let's just use the ternary operator here and do result max val. So if it is greater than 256, if it's 256 or smaller, then we will be fine with 1 byte. But if it's greater than 256, then we need 2, otherwise 1 byte per value. And then also I'm going to make a quick constant because I am going to be reading in chunks of 3. So let's just make a const int that is values per pixel, and that's going to be 3. Just to avoid having magic numbers in the code. Okay, so now let's use that offset we computed before. So if we say, let's come up with a pointer really quick, uint pointer, and this is gonna be a pointer to the pixel data, basically where the pixels actually start. So that's going to be our raw data pointer. Okay, so that's the pointer we got from mmap right here. So raw data, and then we're going to offset it by our offset, and then add one more because there is going to be a new line character at the end of the header that we didn't actually account for with this offset, right? So if I forget this, then everything's going to be off by a byte, and it might sort of look like my image, but it's going to get a bit screwed up. Okay, so this basically pixel data now is pointing to the beginning of where the pixels start in this array of bytes. And now we need to actually allocate our space for our array of pixels, right? So let's take result, pixels, and let's use calloc. That is just a relative of malloc, but it takes two values, basically the number of items and the size of the items. So we'll do result rows, right? So however many rows we need, and then size of pixel pointer. Okay, we're gonna allocate basically a bunch of rows, and then let's go through and go through each of our rows. I'm gonna use Y since, yeah, so it's kind of Y-axis. The rows are the vertical axis of my image. So just to remind myself of that, let's go as long as Y is less than result rows Y++. And I'm going pretty fast. Hopefully I don't make any mistakes here. But then we are going to take result pixels Y, and we are going to call calloc again and get, basically, we know how many columns there are. And so this is how many pixels per row we're going to want. Okay, so now we have basically allocated space. While we're in this loop, let's just go through and let's actually grab the data while we're at it. So let's just go x equals 0, x is less than result. So kind of just like we did before, but now it's the number of columns. So we're going across the column, and then we're just going to go out and grab the pixel information for this particular value. So let's first figure out where the corresponding pixel starts. I'll call this pixel start. Let's do that, okay. And this is going to be pixel data. So that's the beginning of all the pixels. And then we're going to add, we're basically going to shift this over Y times the number of columns times the values per pixel. And we also need to multiply this by the number of bytes per value. Okay, so what we're doing here, so just to make sure this makes sense to everybody, is we're saying, okay, values per pixel. So each pixel is going to have 3 values. Each of those have bytes per value. So we multiply those together to tell just how many bytes are going to be in each pixel. And then these pixels are coming in multiples of, they're coming row by row. So we're going to basically multiply it by columns, which is the length of each row. So it's basically like Y is the row that you're on. So then we're basically saying, okay, well, which row you are, multiply that many rows, and then how big is each of our pixel values. And so that basically allows us to figure out where we need to go in this big array of pixels and start reading at that point. Okay, so that should get us basically to the beginning of the pixel that we want, the pixel that is at row Y and column X. And then we just actually need to basically store it in our struct. So let's come down here and say if, I'm gonna handle this differently depending on the bytes per value. Okay, so if it is equal to 1, then this is gonna be super easy. We're just gonna say result pixels Y X dot R. So the red value, that's going to come first. And then we are going to say pixel start 0. And then let's do the same thing for G and B, and we'll get 1 or 2. Okay, now, so this is what happens if we only have 1, is I'm just going to assign these straight up. If we have 2, then we're going to change this up just a little bit. And instead, we're still going to need 3 values, but instead what we're going to do here is say, I'm going to take pixel start 0, and let's left shift it 8 bits, because now it's a 2-byte value. I want to make sure I get the byte order right. So we'll just basically take these 2 bytes and put them together. Pixel start 1. Okay, so this is gonna be my first value, and it'll be easier, I'll just copy and paste that. G and B, and so then this will be 2, and 3, and 4, and 5. Okay, so we're just handling these 2 different cases, depending on what color depth the images that we're playing with actually have. But this should work, hopefully, if I didn't mess anything up. And then we can just come down here and return result. So this should be all that we need to do to read in our ppm image. Okay, let's come in here and just, while it's fresh in our minds, let's destroy it really quick. Okay, so when we want to clean up one of these things, we're going to want to go through and get the pixel data cleaned up first. So let's say y equals 0, y is less than, image rows, and let's just free image pixels y. Okay, so we're basically going through and freeing row by row by row, and then down here we'll free the whole image. Okay, pretty straightforward, so not much to that. Okay, now last of all, so we've read our image into memory, we can now destroy it. Now let's also get it so we can write it out to memory, and then we'll see if any of this actually works. Okay, so writing should actually be pretty straightforward. We're gonna do essentially what we did before and say fopen file name, only now it is in write mode, and if file is null, so same thing we did before, p error, too many r's, could not open file, and we'll say that was a mistake, a problem. Okay, now just like when we were reading, we're gonna start with the header, and then we're going to write out the pixel data. So let's start with the header with just doing printf. This should be pretty easy because the header is just text. So we'll do write to file, and we're just gonna write p6, new line, unsigned int, new line, unsigned int, new line. Okay, that's what the header is going to look like, where we're going to have columns, rows, and the max value right there. And so we can then just come in here and say image calls, image rows, and max val. Okay, so one line to write the header out, much easier than reading it in, but that's, you know, to be expected here. And then once again, we need to figure out how many bytes per value. So I'm going to come up here and borrow, I'm just going to borrow my code from here, and it's not result, but it's image. And then again, let's just go through y is less than number of rows, not y not I. And then let's also go through setting x, going from 0 to image calls. Okay, so this is gonna go through and get every pixel in the order that we actually wanna store it in the file. And then, now this is really important, we're not gonna use fprintf to write the pixel data because it is binary, it is no longer going to be text. Okay, so this is very important. If you try to use printf, this is not gonna work here. But so instead, let's just do fwrite, and we're gonna start writing. Basically, for fwrite, we're going to first tell it what memory we wanna start from. So that's gonna be, we wanna write the pixel at index yx, and we specifically wanna write its R value. Okay, so this is going to get the address of the R value, and then bytes per val. So that's how many bytes to write, and each byte is 1 byte, and then file. Okay, so this should work just fine. Okay, so this I think will work. It may depend on the endianness of my machine. So I'll have to take a look really quick and see if that's gonna cause me problems. If it does, it will only be whenever there's 2 bytes, which the test image that I'm playing with, this sable.ppm, only has 1 byte per RGB value. So for now we should be okay, but I may have to revisit this. And then down here, let's just return true. Now there is, of course, like right now, so the only error is like if the file doesn't exist. Otherwise I just go, yeah, it worked. There's a lot of other error checking we could put in here. For the purpose of this video, I'm not going to do that because time. Okay, but this should actually work. We should have our module here. I think we should be okay. So I have a makefile here that's going to compile, build my project. It's going to compile my ppm module, and then it's going to also compile my example program, which right now doesn't have much in it. We'll talk about that. So it's empty main, and then a function here that converts hue to RGB value. I'll show you what I'm going to do with that in a second. But let's just make sure this compiles. Okay. Amazingly, I didn't type anything wrong. So it looks like we're okay. So now let's do just a little bit of image processing. So let's say I want to go to my example program. I have these ppm read and write and destroy. So let's come down here and just think about what I want to do here. Let's just first check to make sure that our program, so we're going to run this with a particular file name. So let's say if it is not equal to 2, then we would like to print usage. So print out a usage string telling people how to use the program. So name of the program and a file name and we'll pass in argv0. So this will be the name of the binary, the name of the program, and we will return exit failure. Okay, great. So we check our arguments, make sure that all makes sense. Then let's save a file name character pointer, set that equal to argv1. And so this is going to be our input. Let's also make a character pointer output file name. We'll start that out as null, but we will eventually need to create that. In fact, let's just do that right here. Let's use ASPrintf. Some of you may not be familiar with ASPrintf. It's like printf, but it will allocate space for it. So that will be useful. We'll just pass in output file name. And let's call this, because what I'm actually going to do here is I want to create this kind of rainbow tint to the whole photo. So we're going to do rainbow and then whatever the name of the file was. And we'll grab the base name of the file name. Okay, so this will grab our file name minus any path information, and it will just stick rainbow on the front. Okay, so yeah, so if I pass in like sable.ppm, it will become rainbow sable.ppm. Okay, and then let's just so we get some status information, let's just print out a few things. Let's print out input and a tab character, and then I'm just gonna print out the file name so you can verify that this actually looks like it's doing what you want. Output, another tab, and a string. And then let's add a couple of new lines, and we will basically put file name and output file name. Okay, so that's gonna read in. Let's just verify that that actually, well, we'll return exit success. Okay, so it checks arguments properly, and then let's say we do sable.ppm. Okay, so it's got the file name stuff fine. That's great. Now let's come in here and actually do our readings. So we'll do ppm image equals ppm read image file name. And then just make sure I don't forget later on, we will do ppm destroy image. And we're also going to do ppm write image, and we're going to provide the output file name and the image. Okay, so if I leave it like this, it's just going to read in the image and it's going to write it to a new file name. So let's try that really quick just to make sure it's working. So example sable.ppm. Okay, and so here you can see we get the exact image we started with. We got our sable antelope, but that's not what I actually wanted to do. So let's see if we can make it a little, let's colorify it. Okay, so what I want to do here is just, let's go through pixel by pixel. And what I'm going to do is, well, okay, so let's go we'll go horizontally, kind of column by column, and then down through the rows. And we could go the other way too. It doesn't really matter. And we'll go X++ here. Okay, and then same thing, only Y and by row. So we're basically going to tint every one of our pixels. And like I said, what I want to do is just basically put like a rainbow gradient on this. So you could do anything you want. I mean, they're just numbers, right? So we could make them, take the color out, make them grayscale, or whatever we want to do. Just to illustrate that, let's do something really simple first. So like if I just said image Y X R equals pixels, oops. And let's just say we decided to make the red equal to the blue channel. And we could do the same thing where we say we want to make the green equal to the blue channel. Oh, oops, sorry. Got a little pointer crazy right there. Yeah, sorry about that. Okay, so now if we come over and we said, let's run our example program. So it takes a little bit longer because it's actually going through the whole image. And then if we open up our output, you notice that basically it looks gray. I mean, it is gray because all the values are the same. But effectively what we did is we just grabbed the blue channel and assigned the red and green to match it, right? So we ended up with a gray image rather than a nice colorful one. Okay, but that's not ultimately what I want to do here. I actually want to rainbowify it. So what we're going to do is we want to basically go through the number wheel, right? So we're going to vary. If you look at a number wheel like this one here, we can think of it as having, it's already a rainbow, and we want to go from 0, which is the beginning of the rainbow, to 1, which is the end of the rainbow. So let's make a hue value, and we're going to say, let's make this I want to use floating point math so we get nice stuff in between. We don't get little steps. And we're just going to take y, and then we're going to divide that by the number of rows. Okay, so as we go vertically through the image, this is going to start very small, like around 0, and it's going to end up around 1. And so that's going to be our hue, right? That's the color that we want to tint our image. And then what I'm going to do is come down here and say, let's make a new pixel. I'm going to call it just color. This is the tint pixel. And we are going to call our hue to RGB. I'll get to that function in just a second, but we're going to pass in our hue, and it's going to take the hue and give us an RGB value for that. And then once we have that, then I'm going to make a constant, and we're going to call this weight. And let's just go with 0.5. I don't really know how much, this depends on how much tint I want. So this is like a 50% tint. So if I went 100%, I would lose the original image. If I go 0, I will get no tint. So it's basically how colorful you want it to be. We could play around with that in a minute. But then what I'm going to do here is, rather than what we did before, is we're going to take the original, so we'll take red, and we'll take the original red value, and we're going to multiply it by 1 minus the weight. And then we're going to add that to color.r times the weight. Okay, so we're basically going to get a composite of the original image and the color that we just generated. And then let's just do this. We'll just replicate this for the G and the B. Okay, so G and blue, and then green and blue. Okay, so that should work. That's basically what I want. Really quick, let me run up and talk about what this is doing. I just dropped this in, mostly so this video isn't too huge, but basically it's going to take a value from 0 to 1, and then it comes through, and you can think of the color wheel as having 6 different segments, right? So I've got this number of color wheel segments, which is 6, and so we're basically coming down and figuring out where you are, which segment you're in, and how far in, and then depending on which segment you're in, we mix the colors in different ways, right? So I'm not gonna go into details. If you would like a video on color theory, or how to convert from one color system to another, let me know down in the comments. I'm happy to dig into this in a future video, but this will basically take a hue from 0 to 255, or 0 to 1, not 255, and it's gonna return a color, in this case, in the range of 255, 255, 255. We could, of course, go back and make this actually match the max val for our image. I just didn't do that for today. But now, so if we come in here and we compile it, and let's try to run this really quick. Okay, again, takes just a second, and then we can open it up. And now you can see we have our pretty rainbow tinted sable antelope, and so that's great. If I come in here and, like I said before, if we change the hue, like if I say, I would like this to be not quite so rainbow, maybe we could go down to like 0.2 or something. Make sure to recompile it. And if we reprocess it really quick and then reopen it, then you can see we still have this rainbow tinting, but it is much more subtle. So you can play around with that however you like, but that is the example for today. Hopefully this gives you a little bit more confidence if you ever wanted to do some image processing in your code. So now you have a really simple format that's PPM images. It's super easy to modify. You got an example on how you can read them and write them. So that could be helpful. And so now you can make your own pretty pictures. So I hope you learned something new. I hope this was helpful. Please consider supporting the channel if you're enjoying this. And until next time, I'll see you later. Bye.